Okay, now we are going to do secant lines for the lesson 6. Secant lines are the lines between any two is a straight line joining any 2 points of a function. All right, so this is also known as the average rate of change, or simply the slope between any 2 points of the function. So right here is our secant line. All right, now the tangent line is the line that hits the function at one point. We also have what's called a normal line, and that is the line, and I'm putting a ruler on my iPad and trying to draw it here. The normal line is the perpendicular line to the tangent. So this is the normal line. So it's normal. It's a normal line. And it is perpendicular to the tangent line. Okay? And so those are the 3 lines that we're going to be looking at. Okay? To find the secant line, this is going to be, so we're going to take this point right here is the point x, f of x. And this point right here is going to be x plus h, comma, f of x plus h. All right? So the secant line is going to be the slope. So that's going to be f of x plus h minus f of x over x plus h minus x, where this part will simplify down to h. Does that kind of look familiar? So my question is, does f of x plus h minus f of x over h look familiar? Remember, this is called the difference quotient. Difference quotient. Okay? So that's coming back again. So now we're going to be talking about the difference quotient again. And to find the tangent line, what you're going to do, so the tangent line then is going to be taking that difference quotient and taking the limit as h goes to 0 of f of x plus h minus f of x over h, and that is going to give us the derivative. Okay? And the normal line is simply the slope. It's perpendicular to the tangent line, so you're going to find 1 over the slope of the tangent line, negative 1 over the slope of the tangent line. Okay? And so that's how you're going to find these 3 lines. Okay? Now this section only deals with secant line. So the first thing we're going to talk about in the secant line is we're going to refresh our memory on how to find just the slope of just a normal old line. So slope equals y2 minus y1 over x2 minus x1. So that's 7 minus 3 y values over 9 minus 4. So that's 4 over 5 is our slope. Okay, now you have to remember that this slope is the change in y over the change in x. And it's very important that you think about slope as being the change in y over the change in x from now on, okay? Because that's what the secant is. the secant is going to be the changes in the y values over the changes in the x value. So now what we're going to do is we're going to draw the secant line, the secants on these. So what is the vertex of this function? So our vertex is going to be 4, 3, and this function opens up. We open up, and then we want to find f of 8. So that's going to be 8 minus 4 cubed plus 3. And so f of 8 is going to be the point 869. So we're going to have 869. And so what we're going to do is we're going to graph this, and then we're going to graph these secant lines. All right, so I'm going to graph this, and I'm going to kind of go down here, and I'm only going to graph the first quadrant because it's all we're really concerned with. So x, y, and we're going to 4, 3. So here's the point 4, 3. And then we're going to 869. And so we're looking at this function kind of here. Move that point over a little bit. And this is kind of what the function looks like. So here is f. And so we want to graph this first secant line right there. So this is a secant line. And then it says graph another one from f of x to f of x plus h. So what I'm going to do is I'm going to kind of graph this secant line. So here's f of x is this point, and I'm going to graph this secant line. So there's a secant line, and I'm going to label it SL. And then I'm going to graph another one, and I'm going to go from the vertex over to here. So there's another secant line. And so what we're doing is we're moving our secant line from the vertex, and we're going to just keep going over this way. Okay? And these are all secant lines. Okay? And that's all you're supposed to do. That's it. And so here, right here, for each of these are all x plus h, comma, f of x plus h. That's what all of these are. They're just different x plus h's. And I'm using my first point, my vertex,